why don't we get right into it? And maybe you can comment on a phrase we hear talked about quite a bit, but it's that of an HFC phase down and how that differs from a phase out that we were familiar with dealing with some of our older refrigerants like R12 or R22.
Sure, Chuck. So, in order to explain what the HFC phase down means and how that's different from a phase out, I'll just briefly explain the ozone depleting phase out, right? Like you referenced the R12 and the R22. The key with a phase out of ozone depleting substances was that regulators looked at the volume of production or import into the country and they stepped that down over time to get to zero. And so it was volume based on production and it went to zero. The difference with the HFC phase down is that you're not just looking strictly at a volume of HFCs, you're looking at the volume weighted with the global warming potential of that HFC, and then you're trying to phase down from there. And also, the HFC phase down, as agreed to through the Kigali Amendment to the Montreal Protocol, never actually gets to zero. It gets to 15 to 20% of the individual countries' baselines. So it's an acknowledgement that HFCs are needed for the future in a certain amount, but that it's important to try to drive to as low a GWP as you can get. And so that can be done by using a variety of different solutions, including blending HFCs with HFOs and other materials in order to drive to lower GWP. So let's walk through what that HFC phase down structure looks like, and I think that'll give a better understanding for folks on the line. Okay, so if we look at this example, this is a generic country A. And country A looks like they consumed on average in their baseline years about 10,000 tons of HFCs. And if you just assume that the HFCs that they consumed were about 50% 410A, 25% 404A, and 25% 134A with those GWPs, you can then calculate what the CO2 equivalent ton baseline is, which is each of the volumes times the GWPs. Okay, so you can see that in country A, their baseline for CO2 equivalent tons is 23.5 million. So then what you need to do is take that baseline and start stepping down from there. So it's not a strict volume reduction, it's a GWP weighted tonnage. And so what that does is the market still needs the volume of refrigerants that it needs. Certainly reductions can be made in leaks, in smaller charge sizes, etc. But in general, the HVAC industry still needs to continue to meet the cooling needs that it has. So what you can do is when you transition to lower GWP products, you effectively phase down and reduce the amount of CO2 equivalent consumption that you have. So just in this example, let's take this further. If you had the ability to reduce your 134A consumption and drive it to zero, because 1234YF is an HFO and it's not counted in the quota, you could take those 3.5 million CO2 tons out of the market over time. In addition, if you take the 404A volume and you replace all of that over time with something with a GWP of 1500, which is about a 70% reduction, you can cut out almost 7 million CO2 equivalent tons. So if you do just those two things over a period of time, you can get to a 40% reduction from your baseline years. And so when we talk about an HFC phase down, that's really what we're referring to, is that eventually, as part of the Kigali Amendment to the Montreal Protocol, countries around the world agreed that they would get down to 15 to 20% of their original baseline consumption on a CO2 equivalent basis. They can do that in a variety of ways. Each country needs to set up their own regulation to get there. But this is the basic concept, is that you're not slashing volumes per se. You can use equivalent volumes or similar volumes, but the volume you use is weighted by a lower GWP solution. So hopefully that's helpful, Chuck. Back to you.